everybody was saying that emotions are bad for decision making, and our hypothesis was, if emotions are bad, why are we making emotional decisions? The decisions that we make comes from emotions plus logic and intuition. So if it was something bad during the evolution, we should have lost it. And the fact that we are still making decisions based on emotions shows that there is an advantage to that. For us, the humans, emotions are very complicated. We can just name a few of our emotions, but if I tell you to, or any other human, to describe their emotions, they can just map it to a couple of words, but that is not reflecting our emotional status in a fair manner. So what we did was that we studied how emotions are processed in an area called limbic system, which is at the base of the brain. Basically, that area is responsible for processing all of the emotions and the majority of the decision making that comes in the mammalian brain.
Nima Schei, so good to have you here with me at the Human Zero Day. Really looking forward to having a really thoughtful conversation together about the space we're in, about your own personal journey, your expertise, your understandings, and how you view the world. So thank you very much for being here.
Thank you so much, Michael, for having me, and it's a pleasure to be in a show with you. As we just were talking, you have a very interesting background, and it's a pleasure for me to be with you.
Thank you so much. So Nima, I want to jump right in because you're a pioneer in the context of emotional AI, and in a second we'll talk a little bit about what that means. But with an MD and PhD in computational neuroscience, facial authentication systems, today you're the founder of Hummingbird's AI, and the world we're living in is changing very rapidly. You've been in the context of artificial intelligence for quite some time, so this is may perhaps a rather new phenomena for many people, but for you it's been really a piece of your life's work. So tell me a little bit about your journey up until now, leading up to, I guess, recently. How did you get into the space, and what has been some of your core interests here until now?
Absolutely. So, by background, I'm a medical doctor and neuroscientist. Came from the biology background, and when I was in medical school, fascinated with the world of our brain, how does our brain functions, which is still a fascination for me and for many of us. And basically, I was going to computer science class in order to understand how we can model the brain. We started working on a project which was the first project that brought emotions into machines. Basically, everybody was saying that emotions are bad for decision making, and our hypothesis was, if emotions are bad, why are we making emotional decisions? The decisions that we make comes from emotions plus logic and intuition. So if it was something bad during the evolution, we should have lost it. And the fact that we are still making decisions based on emotions shows that there is an advantage to that. For us, the humans, emotions are very complicated. We can just name a few of our emotions, but if I tell you to, or any other human, to describe their emotions, they can just map it to a couple of words, but that is not reflecting our emotional status in a fair manner. So what we did was that we studied how emotions are processed in an area called limbic system, which is at the base of the brain. Basically, that area is responsible for processing all of the emotions and the majority of the decision making that comes in the mammalian brain. What we realized is that all of these components in the limbic system, they are having a certain role. Some of them are in order to exciting other areas. Some of them are inhibiting other areas. Some of them are responsible for reinforcement learning. So at the end, we created that model. We put it in a controller, a simple controller, and we realized that these controllers that has that emotional decision-making component, first of all, they make better decisions. They have less noise. They have less fluctuations when an external noise is happening, and they need less computation power, because when you see a lion, you just run away. You don't think about your different options, and they are basically faster. So that's a perfect scenario for control engineering, where you don't have access to, let's say, cloud for making fast decisions. So nowadays they have a lot of industrial use cases, from robotics to a lot of control engineering use cases, like for example washing machines, when you don't have access to a lot of computation resources. During my PhD, which is still ongoing, is I was working on small neural networks at the stomach of the crab. So these small neural networks has only 6 to 7 neurons, but they are very complicated and they show behaviors that you don't see them in regular neural networks. So what we did was we created models of that, computational models of that, in order to create more efficient neural networks. Basically, a neural network that has tens of layers, tens of or millions of neurons. You can shrink it down to a smaller scale, more efficient when you learn from biological systems, because again, anything that comes from nature, anything that comes from biology has been passing the fight of the time, and it's the most efficient way that things could be done. So again, learning from biology, transitioning to a company that we created called Bell Research, and then later on Hummingbird's AI. In Hummingbird's AI, what we do is learning from how visual perception is happening, which is different
Hmm.
from the legacy computer vision models. We were able to shrink those computer vision models to be more efficient, and we use that for automating access to the computers. Michael, you come from the cybersecurity world, so you know that the majority of the cyber or successful cyber threats are because of a human error. And the more that we are able to replace humans with automation, we are going to have more security. So what we are doing is that we get access to the camera in real time. We analyze who is in front of the computer. If that person is authorized, access would be granted. As soon as the authorized person leaves or an unauthorized person comes in front of the computer, access is blacked out and the information is protected. I can show you a quick demo. The computer here, the screen is blacked out. In order to unlock the computer, I just need to look at it. It's unlocked. I have access to my information. And then when I don't look at the computer for a few seconds, the screen is blacked out and my information is protected. So I don't need to think about like Control Alt Delete, locking my computer, and then when I come back, entering my password or multi-factor authentication. That being said, we are seeing that we are going to the AI world, AGI world soon, and there are, of course, a lot of concerns about what would be the impact of AI in cybersecurity. And we think that, of course, there are a lot of opportunities, but at the same time, a lot of challenges. And we are very excited to explore them and creating guardrails around the negative side of AI to make sure that AI would be a force for positive impact for the whole society.
Wow. Okay. So many things that I want to dive in. I want to go a little bit into Guacamole ID and a little bit into, I read somewhere you were discussing sort of the amygdala's role in facial recognition and and you mentioned yourself how you're rethinking the context of computer vision and how do you provide and how to do sort of next generation facial recognition. So tell me a little bit about this technology and where we're at today, because it seems to me from a lot from the research world, this context of facial recognition has in many areas been considered almost a solved problem. But I'm curious to hear how when you're fusing it together in the context of nature, how that changes a little bit the game and what new places we can innovate here.
Yes. So two things to set the foundation. One is that we have facial recognition and we have facial matching. Basically, in the facial recognition, it's one to n. You have like n faces. That n could be millions of faces, and you want to find who is that one face that you are detecting among those pool of like n, which can be a large number. That's facial recognition. In the facial matching with like Face ID, you have one face or just a couple of faces, and you want to see if that face that you are detecting matches with the face that is authorized. So the pool is different, and basically the way that you approach the problem would be different as well. Like if in our brain, we our brain is not designed to do facial recognition very well. Sometimes you go to a group of people and you have hints that, oh, I've seen this person, but knowing that who that person is very hard for our brain. So, but we are good in facial matching. Like if I show you two pictures and then 5 months from now ask you who was this person, you can basically recognize them better. So this is number one, and I think it's very important to see there are many unknown unknowns where in our world. Right now, many of the systems that we have designed, like facial recognition, are from the known knowns, like the human brain or the engineers. The facial recognition started from 1950s or 60s. So in that time, they started measuring like what's the distance between the eyes and ears, and the nose, and so these key points of the face, and then try to recognize faces based on that. So it's a mathematical equation that you do and see which face is the closest one with the face that you are detecting. But thinking about AI that would bring unknown unknowns or open doors for us that we didn't know those relationships existed, it can understand the faces better than these measurements. Like there are unforeseen measurements that AI can detect those relationships way easier than the computational or mathematical approach that we are having nowadays. That's number one. And number two is that if you look at the way that our brain functions, so we have different modules, right? Let's say amygdala, let's say orbitofrontal cortex, let's say thalamus, hypothalamus. These modules or these models, they are each one of them is responsible for one thing and do that thing the best way. Like for example, the way that right now we are doing LLMs or RAG, it's the same. Like we are designing a system that is specialized in doing one thing, right? But that thing could be replaced. Like you can replace the state of the art facial recognition models with another one that a couple of years come later with the best one. So when you design the system, it's going to be very important to have that modular design so that you can always replace the components with the state of the art models that are coming in. But talking back to or answering your question, the way that we let's say you go with your significant other to a large party. And you know that what she's wearing, you don't need to have like her face to recognize her. You have a holistic view into what she's wearing, what's her hair color, what are all of those components, and when she's walking among tens of people or hundreds of people, you are still able to recognize that person among that large group. So this is very different than the facial recognition system that requires your face in a frontal and a very specific manner to be able to do that calculation. This is the fundamental differences, that in the biological systems you are having a more holistic view into the shape of the person, and in the facial recognition or more numerical based models, the more legacy systems, you are very much relying on just those measurements and the distances and the biometrics of the face.
Okay, it makes a ton of sense, and I can see how through thinking about this modular design and the comparison or the analogy rather to the human brain, you can see how different modules are performing their core tasks very very well, and then by perfecting on those, you can build an ensemble approach where you utilize the functions of different tuned approaches, which makes a lot of sense. Talk to me a little bit about Hummingbird's AI and the solution, because now you're bringing your research and you're bringing your learnings and understandings to real world applications. You're talking about security. You're talking about the human is the weakest link. We're talking about humans as with the human 0 day. So tell me a little bit about the product more and also in the context of how you're seeing this play out into the market.
Yes. So the product by itself is a software. So it's an AI based software. You install it in your computer. For now, we have the Windows version of that. So it's available on every Windows computer, no matter what kind of camera you have. One of the limitations of technologies like facial matching that you have in your iPhone, called Face ID, or in Microsoft Hello, is that they require a specific type of cameras. And number two is that they only run one time to grant you access to the device. So these two shortcomings have some limitations, like you cannot use them in every laptop and computer. With our system, Guacamole, you can basically use that in any laptop and computer, in any Windows computer, as long as you have a camera, no matter what kind of camera you have. So we have been able to bypass that first limitation to grant access to a large number of population. Number two is that because, again, the computer vision models are computationally expensive, if you want to run them, let's say, 30 frames per second in your device, you would heat up the device and that would affect the battery life, that would affect the lifetime of your device, and probably the user experience. With our system, we have been able to reduce the computation power to just a couple of percentage of the CPU. So it runs locally in the device. There is no data is traveling outside. It's like a rolling window that analyzes every frame and go to the next frame and next frame and next frame. And so the data stays locally, therefore it's compliant, GDPR compliant, HIPAA compliant. You can apply that in the medical settings or any information, any sensitive area, because simply everything is contained locally in a closed loop. And because the system-wise, we are using a very limited computation power, therefore you can run that continuously. What that means is that you have a continuous view about who is in front of the computer. So as soon as the person leaves, you saw that the computer is blacked out. If another intruder comes in front of the computer, we are able to recognize and blocking access if you enable that feature. And so these functionalities are not traditionally available in other facial matching technologies like Face ID and Microsoft's Windows Hello. That being said, as you can imagine, this is can be applied to any vertical, like from healthcare to education to government side to private sector to the consumer side. So what we figured is that you are coming from the world of cybersecurity, and you know that the cost of acquisition in the cybersecurity world is a lot. Like with all the competition that is between the cybersecurity companies and the chief information security officers that are super busy with their all the threats that they're facing every day, it's going to be very complicated to have like the sales team that can address this solution for the enterprises. So instead of that, we said what would be the best approach for this type of solution is that it sits in the computer in the chips, and therefore the name guacamole. So every
Hmm.
computer has chips. It's time for guacamole. And the vision is to basically bring that to every laptop and computer through collaborations with the chip makers like Intel, so that when you buy a new computer, automatically you have this feature enabled inside your computer. And basically you can enable that and use that for regular usage purposes. So it's a B2P, B2C play. At the same time, if you are an enterprise that would want to enable this feature, you can easily onboard the user. We have the system that you can do mass deployment. We have the dashboard that you can manage the users. You can add or new users or remove users, and you can basically use that in large enterprise settings.
And how would the onboarding work? Because it sounds like you are matching, right? There's a matching process so that you're able to identify an authorized user versus a non-authorized user. So how does that work? And is that something that is adaptive to the changing circumstances of a user, or is and how do you do that if this is a strictly on-prem solution?
Absolutely. Very good question. So, first of all, the first part, the onboarding is a very easy process. The onboarding of Face ID, that you rotate your face so that it has the side embeddings and all the angles. But the way that we do it is even simpler than that. So you register your face with a frontal view. But the thing is that because we are having access to the video, we can capture all the angles through the usage of the computer. So as soon as we find a better angle, like in this side, we replace the old embedding with the new embedding. So the system is learning continuously from you, from your changes. So if you grow a beard like me or you change your hairstyle, the system is able to recognize and update it continuously so that you always have the most updated embeddings for that specific face. So that means that the system Guacamole is knowing you through time better and better. The second part of that is we have two systems. We have the standalone version, which is for computers that you have a dedicated computer, like a dedicated laptop. And then for the enterprise settings, we have something called the connected version. In the connected version, let's say you are working in a hospital or a police department or any work that you would change computers in a frequent manner. Like if you are a nurse, you are moving between different computers, many computers throughout the day. So the way that we designed the system is that you would register your face in one of the trusted computers in the network. The embeddings, the biometrics would be extracted, sent through the server through the VPN to the server of the hospital, and then through the server to all of the endpoints that the IT team assigns to that specific person. That means that the IT team can assign, let's say, these 100 computers to that specific phase. And as you're using the computer and the embeddings get updated, there is a heartbeat mechanism between the computers and the server, which broadcasts the updated biometrics to all of the endpoints in a regular and frequent manner.
Amazing. And so, how do you see this play out from an enterprise perspective in the context of identity verification? We have different. Identity has, ever since I guess 2015, really has really taken off and has become a central piece in cybersecurity. And we see companies like Okta emerging and single sign-on approaches. We see zero trust policies enforced across many different systems and multi-factor authentication being deployed. And so this is a, long and understood to be a core problem from a cybersecurity perspective. Where does this fit into the enterprise workflow? Under what are the main use cases that you see, and does it live alongside other solutions in your perspective? Does it replace some of them? How do you envision this?
Absolutely. So we don't replace any of them. We are a supplement to them. So your traditional and legacy identity and access management stays the same. So you would do the authentication, the initial authentication through those systems. Let me give you an example. Right now, if you are again the same example, you are a nurse, you come to the hospital, you go through the multi-factor authentication, two-factor authentication to get access to the computers. Then you go to the next computer, you have to log out from this computer, go to the next computer, do this process again, and then the next computer, do this process again. So basically, you have to go through that process 20 times, 30 times, 50 times a day. In this system, you do the first authentication through that legacy system. So if you were using multi-factor authentication, you do the same thing. But as you are moving between different computers, or you go back to the same computer, anytime that you are not in front of the computer, the screen would be protected with Guacamole. Anytime that you come back, it's going to be unblocked. So you don't go through that repetitive multi-factor authentication process. You do that once, and the rest of that would be covered with Guacamole. So that means that you don't go through that process over and over again. What was the first question, or the missing part of the question?
Well, now that you said this, I already have the. I'm already thinking about where you're taking me next. But if you're looking at the emergence of AI powered threats, and so identity threats, phishing, social engineering, this landscape is quickly evolving and shifting. How do you see that? You're living in the forefront of AI, and I'm curious both how you see the emergence of social engineering threats to try to circumvent these types of solutions. So, what are the most pertinent ones you're seeing, and then how does Hummingbird's AI aim to resolve some of them through your own solution?
Absolutely. Very, very good question. So, again, Michael, you come from the cybersecurity background. I don't come from the cybersecurity background. I'm a very new person to this world of yours. But you know that in the cybersecurity world, for the defense side, you have to be right 100% of the times. For the offense side, you only need to be right one time, right? So there is a mismatch between the risk between the defense and the offense side. As AI comes, it shuffles everything, and it shuffles both defense and offense. In the defense side, of course, there are new tools and very exciting tools that are able to help us. But at the same time, there are many tools that is going to be used on the offense side. So we are seeing a lot of new tools and a lot of new verticals of frauds that they didn't exist just a couple of years ago. Like thinking about how easy it is to do voice cloning now, deepfakes, very easy. And even the technologies of deepfakes, when it comes to video, the technologies that are available in the market are just part of the technologies that exist, but soon there are going to be more and more sophisticated ones that are coming out. I've seen some examples like that. You can very easily generate a behavior or a video of a person, not the ones that are available in the market, but behind the scenes, that how capable they are. And it's going to be very impossible for regular folks to understand that this is a real human or a synthetic human. So nowadays in our fraud, we see that somebody is calling from another country and calls and say, "Oh, I'm your doctor or I'm your banker." And usually, like our older population, our more vulnerable population, they are very prone to these type of attacks, and they answer and they think that yes, anything that anybody that calls and claims that okay, I'm from this bank, that's correct. So the amount of literacy that we have related to the fraud is very low, especially I think in most of the world is very low, and media literacy is another one. Like the when we see something in social media, we believe that it's true, but at the same time, a lot of that that could be a fraud or another form of attack. So I think we need, and there's a clear cry from the community that we need solutions to simplify, makes this more accessible for everybody to be able to understand that this is a real human or this is a video that comes from AI. So when it comes to deepfake, I mentioned Bell Research. So when in 2019 or 2018, Facebook saw this challenge very early on, and they created a challenge with like $1 million prize for whoever can detect deepfakes in a very efficient manner. We participated in that. We didn't win, but we had a good score, and that was the aha moment to come to the route of Hummingbird's AI. But I think we are going to have a lot of challenges with the deepfakes that are coming. We are very much concerned about that. I also started an organization called Miami AI Club last year, a little bit over a year ago. That we figured that many of these technologies could have a lot of impacts, and we haven't foreseen that impact, and we are not prepared for that impact. So the goal of this community is to basically create a positive impact through AI and figure out where AI can be misused or abused, and then try to build guardrails against that. That being said, deepfake is one of the most important verticals in our focus. So we created the first community-driven proposal for National Institute of Standard and Technology in the US to basically create guidelines for NIST to how to address some of these challenges with deepfakes. For example, in detection, in labeling, and different strategies in order to mitigate the risk of deepfakes. We did a research, a survey with global business leaders and public sector leaders in order to understand how much they are prepared for deepfakes. And the results, we are going to publish that next month. But the results, I'm going to give you a hint. The level of that we are prepared is very close to zero. We know the problem, but we are not prepared for that. So I call it
And
like
so, Nima, tell me, this is fascinating. Tell me, let's talk about preparedness. So, one, I'm curious, you've been in the deepfake space then from 2019, 2020. I remember the publication of the DFDC challenge, and I was following it closely during my studies at Stanford. Why? So, where were you at when this challenge came in? You must have been thinking to yourself, "Wow, this is a really big problem that should be addressed." And I mean, when you're talking about nature and biology in the context of humans, I mean, this is the mimicking of human behavior, and if not from just the visual but also the emotional sides. What are the relevant solutions in your perspective, detection or otherwise, and how did that meet your own journey and your own decision making as an entrepreneur?
absolutely, that's a very good question. So when we faced that challenge, one of the biggest problems that we figured was the amount of the computation power that is needed in order to detect if this video is a fake or a real one. Like running these computer vision models for video analysis is very expensive and not something that can be done locally in the device the majority of the time. So we figured if these technologies could be having a real impact for deepfake detection, it needs to be very much lightweight and something that can be applied in regular computers so that we don't rely on the cloud. Because if it's on the cloud, there are some complications with that. Like, for example, the cost is too much. Like, imagine how much expensive would be the cloud cost of running all of these videos on the cloud. Another one was, of course, the privacy, security aspect of that, the latency, all of that would be some blockers in order to run these models on the cloud. So that was the aha moment to why not use the build systems, the emotional systems that we created in 2003, 2004, because what we learned from those controllers was that the bio-inspired ones, they are way more agile, way more lightweight, they make better decisions, and they need less computation power. So it makes sense to apply them in this scenario. So we created a system based on the same structure of the base of the brain, again, the limbic system. And if you look at it, it does make sense. Daniel Kahneman, the award-winning, the Nobel Prize winner, I think he was in Stanford too. He also mentions that in his book, The Fast and Slow Pathways. So in our brain, we have that fast pathway, the fight or flight response. When we see a lion, we just run away. And then there is a slow pathway. Like when you go to a room in a millisecond, you have a sensation that, oh, this room, it feels comfortable or it feels very scary, or I should be very much on my toes to run away. And then there are like the slow pathway. You start analyzing things. Okay, who is in this room? What's the color of the room? What are the threats that I might face? So that fast and slow pathway is very helpful here, because then you can use the fast pathway in order to remove a lot of the scenarios that you would you are confident that these are very much fake, and you don't need to put a lot of computation resources into going into the details of that. And then the slow pathway, when you are seeing that, oh, this might be somehow in the gray zone, and somehow I'm feeling halfway and I'm not completely sure. So you have the luxury of the time and more computation resources in order to analyze those videos in a more detailed manner.
And so, if we're looking into the future a little bit, 4 or 5 years, usually it didn't seem like to be a long time, but in today's world, we're going to be in a whole different society in 4 or 5 years. Looks to be. So, what are the right or relevant solutions to be fighting these types of AI-powered phishing and threats that could really undermine, society's ability to distinguish between what is real and what is synthetic? What are the right approaches in your perspective?
Absolutely. So what I'm saying is that first, you pointed a very good thing, that 4 to 5 years nowadays is looking a long time, and I do agree with you with like the AGI that is coming, artificial general intelligence, and the amount of it's a powerful tool. The more powerful the tool could be, it can, in the right hands, it can be a good tool, and then in the wrong hands, it can be damaging to the society. So I think now the good side is behind. The defense side is behind with AI, not even with AGI. And AGI is going to make that worse. So I don't think that we would, this is my personal opinion, I don't think that we have enough resources to defend ourselves for an AGI world. I think we are, at the best scenario, we are getting ready for the AI world. So we need a lot of innovators and a lot of outside of the box thinkers in order to come and disrupt things, see things differently, and comes up with new strategies in order to mitigate that risk. That is a risk that cannot be done or be addressed by one person, one group, one individual, or one country or one government. It requires a lot of cross-industry, cross-border communications and collaborations in order to be able to mitigate that risk. And I think that with one direction, with one solution, it's going to be very hard. We need to have like a syndicate. We need to have like a group of technology companies working together in order to be able to mitigate that risk.
And that speaks, I guess, to your own strategy, which you mentioned about 25 minutes ago in regards to Guacamole ID, in that you're not fighting or you're not pulling away from existing solutions. You're a supplement to the existing solutions, looking at how do you augment the already myriad of solutions that exist, but adding new ones along the way. And by the way, the demo looked very, very cool. When you're talking, when in the context of enterprise security, humans are the weakest link. And if we're looking at the evolution of deepfakes and social engineering attacks, how do you find security professionals? You mentioned that you're going to release a survey rather soon, but how do you see their awareness and their, I guess, willingness to innovate, to adopt new solutions, to think differently from before? Because there have been identity security tools in the past, and there have been, email security solutions up until now. Obviously, nobody's monitoring this call that we're here. I hope that you are you, but I didn't see anything running to verify that. Where are security professionals, these busy CISOs, with this problem space?
I think the CISOs know the fact that this is a new vertical. And what I'm seeing is that, of course, they are having a lot of threats that are coming, and the cybersecurity world is becoming very complicated for the CISOs. So I think the level of that they are prepared for this is not that much. They are hoping for the best. But this is a problem that not only affects the CISOs. This is a problem that affects the elections. This is a problem that affects the integrity of the news, media. So it's a multidimensional problem, and a problem that needs to more of outside of the CISO people to also address this problem and try to stop that. Like, for example, I know that Department of Justice, they are working on solving this problem, right? But there are many cases that they are seeing, like in the courts, that there are videos of the teachers that they are not the teachers, but saying something or doing something that is not right. So imagine how many new cases are going to the courts and bombarding the court system. So it's not only the problem of security, but it's a societal problem that we are going to face. And for that reason, I think it's not only a problem of CISOs, but a problem of every layer of it's a problem of the boards. It's a problem of every layer of the executives. Like if you are the CFO, you would need to know what's a deepfake, because we have seen cases that they're drawing like $25 million from a bank account. If you are any person in or any decision maker in an organization, you need to be prepared for these attacks.
Yep, and I think that we'll remain curious to see how the right solutions get implemented, and what are the right solutions that really integrate into the workflow. Because I think that what's going to happen is that we're going to have to effectively reinvent a lot of the way that we've been thinking through digital communication and digital interaction. And how do you create a layer of trust in the authenticity of the communication between people that is in some level reliant on automations in the backbone, because our human ability, the ability of our amygdala to continue doing what it's doing, well, it's still going to be good, but it's just not going to do what it needs to do, because you'll just look exactly like you. And so we
Absolutely.
weren't primed for that.
You said a keyword that is very important, and that's trust. So trust that comes from authenticity, because nowadays we are living in a digital world and soon in the AI world, that we really don't know who we are interacting with, and if we are receiving a content, if we are receiving an email, who is it coming from? So I think we need to rethink that. We need to find ways to be able to bring trust back to our communication, and you address that very well. We need to make sure that the humans are real humans. We need to make sure that whoever is on the other side is really who they are. It's not their deepfake. It's not their somebody that it's impersonating them. And without that, we are going to have a lot of problems. So that is the missing part of the internet or digital interactions that we have now.
Nima Schei, thank you so much. This was a wonderful conversation, and thank you for the great work you're doing with Hummingbirds AI. I look forward to keeping in touch, and thank you for all the great insights.
Thank you so much, Matthias. It was one of the best podcast experiences. I think your smartness, your achievements were resonating. It was like shining through the conversation, and it was a very pleasant experience for me. And I'm glad to be this morning with you.
Thank you so much.